looping construct enforces you to go from top to some line, then again coming back to top and some line, again coming back to top and some line. We call it iterations. During this invention and implementation, GoTo was in practice since long. But the only problem with GoTo is they don't have predefined sequence of movement. And what is that? If we go for if, we definitely are very sure that how if is going to work. If condition is true, we enter true part and false part is ignored. But if we enter false part, true part is ignored because of decision is false. In case of looping, either loops are entry control or exit control, where conditions are either checked first and then you enter the loop, or conditions are checked last and you are repeating loop again if condition is true. But in all these cases, you are very sure from which point to which point your flow of control goes. In case of GoTo, the biggest risk is you put label anywhere and you mention GoTo anywhere. You can go from bottom to top lines, or even you can go from top to bottom lines. This happens definitely according to programmer's wish, but this creates confusions when in future programs are modified and a new programmer or maybe programmer who is modifying it further does not know the intention of using GoTo, and it might happen that GoTo creates misconfusing results. So GoTo is definitely part of programming. If you know its wise use, you can use it. But if you are a bit confused what will happen to future, then don't use it, because generally GoTo creates confusions in future during program modification and debugging. The next example what I have on screen is example of printf. In my program, variable a is initialized with value 5 and I want to print its value using some pre and post incrementing operators. So my printf statement contains %d, %d and %d. The first value given is using a plus plus a. The second value is given using a plus plus, and the third value is given using plus plus a. And in case if this is asked in theory, most of you are writing wrong answers. According to general belief, what happens is a is given 5. Now first variable is plus plus a, so post increment, and method of post increment is increment value first and then give value. So a is now incremented to 6 and this 6 is given to %d. So first output is 6, then second value is a plus plus, means you take value and then increment it. So the same 6 value is given to second print %d and then it is incremented to 7. So first value is 6, second value is also 6, and third value is plus plus a, where already a is 7, which is again incremented by 1 and it is given value 8, and then this value is given to %d. So what we are expecting is its outcome should be 6, 6 and 8. I have the same example. In this example, I have given plus plus a plus plus and plus plus a, where my value is initialized by 5. Let us execute this program to check its output. The output is almost reverse to our expectation. How does it happen? Your concept is not wrong, but the only line to be mentioned here is printf starts processing variables from last and starts assigning value from first. You should remember this. it starts processing your values from last. So value of A is 5. It starts processing variables from last because this variable requires processing. Simply, if it is variable, we don't require processing, only values are replaced in sequence. So first value is given to first %d, second value is given to second %d, and third value is given to third %d. But in case you require processing, processing starts from last. So first value is incremented to 6 because this is pre-increment, and this contains 6 value now. Here the next value is 6 and it remains as it is and then incremented. So it becomes 7. Now third processing is first incrementing value and 7 becomes 8 and then value remains. So sequence is first this is processed and value is 6. Second this is processed and value is 6. And third this is processed and value is 8. Now replacement occurs where 8 value is given to first, 6 value is given to next, and 6 value is given to last. And so we have this result. So result is not wrong, but the only thing to remember is whenever we start processing variables listed in printf, always we should start it from last and then previous, then first, and then replacement. So definitely replacement occurs in sequence, but processing starts from last and comes to first, and that's the reason why we get this answer. I have one more example which clarifies what is return from the printf. We never see full syntax of what of functions what we are using in our programming. Printf is used in almost every program you write. But do you know what is return type of printf, or do you know what is return type of scanf? In case you know, it is better, but if you don't know, it is important for you to know. When you use printf, generally printf is used to take string from you and to write it into output buffer. We call it standard output buffer, and generally we associate standard output buffer with our monitor. So when printf is given some string, a string is written into output buffer, and how many characters are written into buffer is returned back to you. So when you write printf in bracket double inverted comma hello, HELLO, ultimately the output can be hello on screen, but if you store its value into variable as a returning value, you are going to get count. Hello contains 1, 2, 3, 4 and 5 characters. These 5 characters are given as a string to printf. Printf writes it to output buffer and it returns you that I have written 5 characters into buffer. So the output what you are going to get is hello, but the return what you are going to get is 5. Generally we don't store it into variable, and so we don't know exactly what we are returning, what we are getting back as return from printf. So printf is responsible to write characters into output buffer, and it also equally important to know that printf is also responsible to return number of characters successfully returned into output buffer, and that is given back to you as a returning value. And to understand this, I have example. In this example, a pointer is declared, and for pointer a string is initialized. So you can imagine a memory allocation occurs and hello world string is stored there, and this pointer contains starting address of where this string is stored. In short, you can consider str as array. And now in printf what I have written, %d, and next is printf %s and string. Now can we write printf inside printf? Of course yes. You can call function anywhere because it is part of executable statement. So here this printf is considered as executable line, and it is executed first. So this line is executed where string is taken from the given variable, is given to %s. The same string is given to printf, and on screen what you are going to get is hello world. But as I told you, printf has two responsibilities. First responsibility is to take string from you and write it to output buffer, and the second responsibility is to return you how many characters are copied, are returned into output buffer. So this printf is responsible to take hello world and show it on screen and giving you back number of characters returned. So let us count how many number of characters returned. 1, 2, 3, 4, 5, including space, 6, 7, 8, 9, 10, 11. So total 11 characters are given to this printf. Those 11 characters are returned successfully into buffer. So instead of this entire statement, what we are going to get returned is 11. Now that 11 becomes input for %d. That 11 is copied into %d, and finally that 11 is given to printf, and now this printf puts the same 11 characters, matlab 1 as a character to output buffer. So our output would be hello world followed by 11, and this statement proves that printf is returning number of characters copied into buffer. In fact, for this printf, if you store returning amount into some variable, you are going to get 2. Try to understand. This printf gives 11 as returning value, which is given to %d. %d is converting 11 into 2 characters, 1 and 1. And those 2 characters are given to printf. Those 2 characters are returned into output buffer. And finally, how many characters are returned? That is 2. And so in case if you store return of this printf into some integer, you are going to get 2. That's how this example clarifies that printf has 2 responsibilities: taking string from you and writing it into output buffer, and also giving you back number of characters returned into buffer. I have one more example which explains difference between auto variable and static variable. The first line is a void main. The second line is declaring integer I, and I is initialized with the value 10. The second line is static integer x is equal to I. Now you might be knowing what static variable is, but the point which I want to clarify is generally not discussed or visualized during theory as well as practice. Static variable is a memory resident variable. Static variables are always declared first before we enter the function, and after exiting function even they remains into memory and they are available during next visit to the same function. So in our example, main contains static variable. The name of static variable is x. This variable is declared first even before entering main, and once I exit main, it remains into memory and it is removed out of memory only when I exit program. And that's why if you compile this program will give you error. And the error indicates any static variable cannot be initialized with auto variable, our routine variable. And it is very interesting to understand its reason. Its reason is static variables are declared in memory first, even before entering function. As soon as your function is called, all static variables are declared, and you can compare this scenario with some global variable. Global variables are declared as soon as you invoke, you execute your program. Same way, static variables are shifted to memory as soon as you invoke function. So when this static variable is moving into memory, there is no existence of variable I, because variable I is your local auto variable and it is declared as soon as the syntax is found. But as I told you, static variables are declared even before entering the function. So while declaring static variable, compiler finds problem. Compiler wants this to be declared first, but declaration expects declaration of I, which is impossible because all static variables are transferred to memory. Then we enter function and then we declare all local variables. This is really very interesting. If you want, you can try, and instead of making I as local variable, try to make it global variable, and the same example would work. Because all global variables are shifted to memory first, then all static variables related to called function are shifted to memory second, then you are entering function, and then all local variables related to that function are added to memory. As soon as you are exiting function, all local variables are dereferenced, matlab not used, removed out of memory, but static variables remain as it is till we are ending the program, almost similar to what global variables are doing. So if you are initializing any static variable with local auto variables, your compiler itself knows that this is not possible, and that's why it might give you error. So don't ever try to initialize any static variable with your local variables. The next is in my program, what I have declared is integer variable I, and this integer variable I is initialized with decimal value 320. Here it is very important to understand exactly how integer variable is storing our value. Though I have taken positive number as example, negative number is even more complicated, but I just want to show its calculation and exactly how your data gets stored into memory. I am taking help of calculator. Almost every computer contains calculator, and if you have such calculator, go to view and make it programmer's calculator, which helps us a lot. You select decimal, it is given here,